Alright, everyone. New video here on the channel. Before the video starts, go ahead and leave your like, subscribe to the channel so you don't forget during the video and to help the cause of science communication in Brazil. Here I'm going to talk about what? About Pluto. Pluto, for me, is perhaps the most interesting, most intriguing object in the solar system that we have. I think it's sensational. An object that, unfortunately, was demoted to a dwarf planet. I don't really agree, but then again, who am I in the grand scheme of things? But I don't agree. Why? Because Pluto has a whole very interesting dynamic, both geological and atmospheric. Remember that Pluto has an atmosphere. And Pluto's atmosphere is very cool, okay? Very cool indeed. When the New Horizons probe passed by there in 2015, well, it passed by in June 2015. By the way, its anniversary is coming up, isn't it? That's right, man. It's going to be the anniversary of New Horizons. Look at that, passing by Pluto, 10 years, huh? 10 years for New Horizons at Pluto, is that right? Wow. It just hit me, that's right. New Horizons will be 10 years old now, okay? So, when New Horizons passed by there, 10 years ago, it discovered the following, that Pluto's atmosphere has a haze, as we call it, a mist, which is something very, very interesting indeed, okay? But this, when this data was collected, there was a researcher who analyzed this data and he said the following, "Look, everyone, the haze on Pluto is different from other planets. Because on other planets, the haze is normally formed by gases, and so on. But not in Pluto's atmosphere. Its atmosphere is dominated by haze particles. And it's these particles that end up controlling the object's entire energy balance." At the time, this idea was considered a crazy idea about Pluto. No way, Pluto shouldn't do that or anything. But there was no way to prove it. Why? Because the researchers, when they did this study, they said the following, to prove it, we would need a very powerful infrared telescope. Because those particles, that haze, it would emit strong radiation in the mid-infrared. So, then we could, with a large telescope, prove it, with a large telescope and in the infrared we could prove it. This idea is crazy, as I said. Why? Because in other objects in the solar system, this energy balance of the atmosphere is controlled mainly by gases. And Pluto's would be by microscopic solid particles suspended in the air. Look how interesting that is, okay? All right. It needed a large telescope, in the infrared, to prove this. Then, who appeared? It did. The James Webb Space Telescope enters the scene. When the James Webb appeared, was launched and all, the researchers decided to point the James Webb at Pluto. This happened there in May 2023. They pointed the telescope there with MIRI. MIRI is a mid-infrared instrument, meaning exactly the wavelength at which the particles of the haze in Pluto's atmosphere would respond. And then the researchers were able to confirm that what controls the energy balance of Pluto are solid particles in the haze of its atmosphere. The haze of Pluto was emitting infrared radiation exactly as the theory had predicted. Look how awesome that is. So, the telescope was used to confirm a major theory in planetary science, that what controls the energy balance of Pluto are solid particles. This phenomenon, now proven, makes Pluto's atmosphere completely different from any other atmosphere in the solar system. It's as if we discovered that one of the most distant members of our family operates with completely different rules from the others. Look how interesting that is, right? In addition, the data also confirmed another prediction made by the researchers at the time about the curve, about the rotational light curve of Charon. Since Pluto is very close to Charon, the two have a very strong connection, right? Everything you discover about Pluto also ends up leading to discoveries about Charon. And why is this very interesting? Well, this is interesting for the following reason. Before oxygen accumulated in the Earth's atmosphere, about 2.4 billion years ago, life already existed. But at that time, Earth's atmosphere was totally different. It had no oxygen, mainly nitrogen and a lot of hydrocarbon chemistry. It didn't have that. So, look how interesting. The haze and chemistry of Pluto's atmosphere can serve to give us ideas of how the Earth became habitable in the past. That is the most interesting thing. Why? Because the Earth may have started to have this haze, these solid particles accumulated in the atmosphere. This began to regulate the planet's temperature, began to regulate the planet's energy balance. With that, the Earth's atmosphere began to be exchanged, transitioning to an Earth with oxygen, with nitrogen, with hydrocarbons, and thus making the planet habitable. So there you have it. The James Webb Space Telescope showing its versatility. That's the first thing. I showed it here observing very distant galaxies. It just discovered, right, the most distant galaxy in the universe, M11Z14, from 280 million years after the Big Bang. And with the same quality and the same perfection, it can study Pluto, which is an object here in our solar system, close, relatively close. Pluto is damn far, but in terms, when compared to the galaxies that the James Webb observes, Pluto is very close. So, this is the great power of the James Webb Space Telescope. Its versatility, observing close objects and distant objects with the same quality, with the same perfection. Incredible data, impressive data that allows us, then, to understand the universe, the solar system in a way that is ever better, ever more well understood. So there it is, the James Webb Space Telescope proves a crazy theory about Pluto that has important implications for how the Earth became habitable. Alright. Folks, this was the video I wanted to bring to the channel for you now. I hope you liked it. If you liked it, you know the drill. That big slap on the like button, a flying kick with everything you've got. It helps the video and the channel gain relevance a ton. Never forget the YouTuber package. Share, favorite, subscribe to the channel if you're not already subscribed, leave in the comments whatever you want to know. We're in this together, day and night, in the fight against bad science communication in Brazil and against the anemia in the communication of astronomy in our country. Once again, my name is Sergio Sacani. I am the editor of the Space Today blog, and you have just watched another Space Today TV.